Hello my dear children, I hope you all are fine. I welcome you all to today's physics class. Children, after all, physics is the study of nature and it is concerned with the study of nature and the matter in it. Today, we are going to discuss and learn about some natural phenomena. In your previous classes, you have learnt about storms and cyclones and how we can protect ourselves from storms and minimize the destruction which is caused by them. So, today we are going to learn about some more natural phenomena, that is lightning and earthquakes. You all must have seen electric sparks sometimes or the other, either on electric poles or sometimes in winter days when we change our sweaters, you must have seen small sparks coming out. This phenomena is quite common when the wind is blowing and shaking the wires. You might also have seen sparks when a plug is loose in its socket. Lightning is also an electric spark, but on a huge scale. In ancient times, people did not understand the cause of these sparks. They were therefore afraid of lightning and thought that it was the wrath of gods. But now of course, we understand that lightning is caused by the accumulation of charges in the cloud and we need not be afraid of lightning, but we have to take precautions to protect ourselves from the deadly sparks. As early as 600 BC, the Greeks knew that when amber was rubbed with fur, it attracted light objects. You also must have seen when you take off your woolen or polyester clothes in dark. In 1715, Benjamin Franklin, an American scientist, showed that lightning and spark from our clothes are essentially the same, but it took thousands of years for this realization. Actually, it is the transfer of electric charges from one body to another. Now children, let us perform some activities and learn more about these charges. Children, you all must have done one very common activity sometime or the other. That is, you must have played with a comb and bits of paper. After running the comb through your hair, which must be dry of course, you must have tried to lift papers without touching. I too have a similar activity which is quite magical. Let us see. I have some thermocol balls, a plastic tube and a synthetic cloth. I rub this plastic tube on the synthetic cloth and after rubbing I bring it close to the ball. See what has happened. The thermocol balls have got stuck to this plastic tube and if I try to bring the thermocol balls near each other, you will find that they just move away from each other. How much I try to bring one close to the other, they just repel each other. Isn't this interesting? We shall learn why is this happening. Children, I will show you a model of an electroscope. This is the model of a simple electroscope. There is a bell jar in which I have a metallic wire and two metallic foils. As you can see, these two are two separate foils. I put this foil in this bell jar and attach it by the help of a rubber cork. Now, if I bring a charged object near this metallic wire, what happens? Let us see. I have a plastic pipe and I have a synthetic cloth with me. I rub this plastic pipe on the synthetic cloth. By this process, I have charged the plastic pipe. Now, I shall take this near to the metal wire. I will not touch it to the metal wire. Let us see what happens. Could you see the leaves, the metallic foil got repelled from each other? Why did this happen? Let us do it again. The same thing happens. Children, this is also a model of an electroscope. The electroscope model which I showed you earlier was not that prominent, in which you could see the deflection of the leaves. In this you can see the deflection more prominently. Let me show you. Again with the same plastic rod and the cloth, I rub the plastic rod on the cloth and I bring it near to the electroscope. This metallic part of the electroscope is connected to the two pointers which are there inside the electroscope. Just see what happens. Could you see the deflection? Now see what happens when I touch this metallic part. When I touch this metallic part, what happens is that the charges which were present on this metallic object travel through my body into the ground. This is what we call as earthing. By these activities, we shall see how these charges are related to lightning in the sky. After seeing all these activities, can we say that there are two kinds of charges? Can we also say that the same kind of charges repel each other, whereas the charges of different kinds attract each other? What do we call these charges as? So, it is by convention that we call a particular type of charge, like the charge acquired by a glass rod when it is rubbed with silk, as positive, and the other kind of charge as negative. When a charged plastic rod is brought near the thermocol balls, then there is attraction between the two, whereas when a charged plastic straw is brought near another charged plastic straw, there is a repulsion between them. So, what do you think would be the kind of the charge on plastic straw? Will they be same or will they be opposite? So, these electric charges are generated by rubbing one body to another. That is why we call them as static charges. These charges do not move. They are static on the surface of the object. When the charges move, they constitute the electric current. This is the same electric current which makes a bulb glow in a circuit. But how do we detect the presence of charge in a body? Do we have any device for that? Let us see. Let us do an activity by making this arrangement. We have an empty bottle and a piece of cardboard with a small hole pierced into it, so that a metal wire or metal clips can be inserted. We have taken two strips of aluminium foil and we have pierced a hole and we have inserted those on the metallic wire. Now, we will charge a body and touch with the end of the metallic wire. What do we see? Is there any effect? Is there any effect on the metallic foil? Yes, we saw that these foils are repelling each other. So, now we touch the other charged body with the end of the metallic wire. What happens to the strips? They again come back to their original position. So, how do we explain this? When a charged body is brought and touched with that part of the metallic strip, then some charges which are of the same kind, they flow into through the metallic strip into the aluminum leaves. So, when the same kind of charges are present in both the leaves, they move away or they repel each other. When we are touching the wire with a charged body, then the charges from the body are flowing through the wire to the metallic foil, as a result of which there are similar charges in the metallic foil and the foils repel each other. But when we touch the metallic wire, then the charges from the wire flow through our body into the ground, and hence there is no more charges on the metallic leaves. So, they come back to their original position. When the charges flow from the metallic foil through our body to the ground, then we say that the strips are discharged, and this process of transferring of charge from a charged body to earth is called as earthing. This device which we made is called as a simple electroscope. Electroscope is the device which is used for detecting the presence of charge in a body. So, children, today we have learned that certain objects can be charged by rubbing. We also learned that there are two types of charges. The like charges repel and the unlike charges attract. We learnt about the construction and working of a device called as simple electroscope, which is used to detect the presence of charges. Before ending today's class, here is an interesting task for you. Children, you have to find out about the famous experiment done by Benjamin Franklin. It is called as Benjamin Franklin's kite experiment. So, please try to find out about that experiment. I hope you all have learnt and enjoyed in today's class. In the next class, we are going to learn some more things about lightning. That is, we are going to learn how lightning takes place and what safety measures or precautions should be taken during lightning. Till then, stay safe, take care and keep learning. Thank you all.